In this one, we could try and find the little area of those three little blue areas. Or we could look at it as that if I find the area of the circle, that would be if this whole thing was filled in, right? It would all be blue if I find the area of the circle. And then just subtract out the area of the triangle. That's probably the easiest way to do it. And I don't believe you have the measurement in there, do you? I think you do now, though. You know the radius of the triangle and the radius of the circle are both 8 meters. So a pretty big object we have here. So let's go over here and find the area first of the circle. We know that formula. We just learned it. It's pi r squared. So pi, radius is 8 squared. So 64 pi meters squared. Then you have to decide, is exact going to help me out better or is rounding going to help me out better? How about that triangle? Do you think that triangle is going to have a pi left in it when I get done doing that thing? No. So is pi really probably going to help out a whole lot in the end? Probably not. So let's just go ahead and let's just go to decimals. So we'll go, well, that's about 64 times 3. So I got 201.1. And again, it would still be meters squared. So let's just put a box around that answer so we don't lose it, because you don't want to be looking for that later and you can't find it. So that would again be if this whole thing was just all filled in blue, everything was blue, that would be 201.1. That's not what I want. I want to take this and basically erase it just like that. And so we're going to find the area of that triangle. So the triangle will go down here. Once again, we have a choice. We could do base times height divided by 2, or we could do 1/2 perimeter times apothem. Well, if we have the radius, we might as well go and do it this way. Because once again, we would know each of these to be 60, meaning this radius cuts it in half to be 30, just like that. And so we're going to go, it's probably just quicker to do it this way. Well, we know the over 2 part. Do we know the apothem? Well, not quite yet, but we can figure it out pretty easy. The apothem is this one right here, and I can get there by dividing by 2. So it's 4 meters. All right. So I now need to go and get that one. All right, hopefully that was enough time to figure that out. Is it going to be more than 4 or less? Better be more, right? Because 4 is across from 30. Going to be more or less than 8? Better be less. 8's the hypotenuse. And again, you could just say that you're going to multiply by square root of 3, so it's 4 square root of 3. But does our other answer in this problem have a square root of 3 in it? No, so square root of 3 is probably not going to be a very helpful way to have that. So what is that in decimal form? 6.9. So 6.9 is that much of it. And how many of those little pieces am I going to have? Once again, 6. Can multiply that out, and I got 41.4. So is 41.4 the area? What is 41.4? Oh, it's the perimeter of the triangle. But you see how if you get distracted, you could forget what it is you just typed in? Well, I got 41.4. So you must have used something other than 6.9. Perhaps you used the full decimal. It's very possible. So you take 41.4 times 4 and then divide it by 2. Or personally, I look at it as 41.4 times 2. Which leaves us with 82.8. And once again, that's meters squared because I took meters times meters. So we got a red answer of 82.8 meters squared and a blue answer of 201.1 meters squared. Of those two, which is the answer? Yeah, neither one. You have to subtract. So we have 201.1 meters squared minus 82.8 meters squared. Do the meters squared go away then if you're subtracting like that? No. See, you know that here. But if I were to put x squareds in there, you might have come up with a different answer to that question. I got 118.3 meters squared would be just the shaded region. And remember, this is what some people do for these once they get this far. Whenever they get to a regular polygon, they'll find the area of this triangle and then take it times how many of those triangles would be in there. Because you've got your base and your height. Okay, and some people do it that way. Okay, so whatever way is going to work for you. Any questions? Well, this one we have a square and a triangle. Most people are confused as to why my triangle doesn't reach the top. I will show you why the triangle doesn't reach the top, although the smartboard really wanted it to reach the top, but it's not supposed to. In this one, in the last one, is it supposed to reach in all three locations? Yes, it is. It's supposed to hit that circle perfectly. Unfortunately, it does not do that with a square. Well, I think the square is pretty simple. Could I do perimeter times apothem divided by 2 for the square? You could. Way too much work, because it's way easier in this case just to do base times height. So you got 10 on the side there, and obviously we've got 10 up there as well, and so the square is simply 100 square centimeters. And chances are, if you actually went and did perimeter times apothem divided by 2, you would have got 99.9 or 100.2 or something very close, but not quite exact, because you'd have to round. So that's our square. We know we have to subtract the triangle. So here we go. In this particular instance, we know the bottom is 10. So here's how I would actually do the problem, because I think it's easier. This is 60. That's 30. I would actually do base times height divided by 2 because of the information I was given. Could you still do perimeter times apothem divided by 2? Sure. It would come out very, very much the same. But if we know the whole bottom is 10, how much is that little piece that I just kind of outlined in blue? 5. So do you see how your 30, 60, 90 does kind of get turned a little bit from the other one if you were doing perimeter times apothem? But it's still very, very similar. And I'm across from 30, and I want to get across from 60, so the value has to get bigger. So to get there, I have to multiply by square root of 3. Once again, did I have a square root of 3 in my other answer that we were working with in this problem? No. So square root of 3 probably not very helpful. And well, what is 5 square root of 3 then? 8.7. So do you see how this, if that's only 8.7, should it be reaching the top of that square? If this much is only 8.7, I just drew in red, it better not be touching the top. Okay, that's just how the two objects work together. So once again, some of you are like, what's he doing? Well, area is base, I don't know where that was going, base times height divided by 2. Well, what is the base of this thing? The base is, all the way across is 10 times the height we just found of 8.7 divided by 2. I'm trying to show you that even though they are regular polygons, you don't necessarily have to use perimeter times apothem. You can. So basically, I look at that as 5 times 8.7. And you get 43.5, right? And the label on that one is also centimeter squared. Is that the answer then, 43.5? No, 100? Nope, you have to subtract. And again, does the label hold? Yeah, it doesn't go anywhere. It doesn't become centimeters to the 4th. It doesn't become just centimeters. All right, it stays. And show the shaded region. 56.5. Any questions?